Hi, my name's Tobias from MATTR, and today we're going to talk about a spec called the OpenID Connect Credential Provider. For those familiar with OpenID Connect, it is a hugely popular user authentication and identity protocol for the web. Many will be familiar with its usages to enable third-party login to many websites. Those who have seen the sign in with Google and sign in with Facebook options that are prevalent on most login pages today, under the hood, we'll note that OpenID Connect as a protocol has been used in order to facilitate those interactions. And with this technology and the extraordinary amount of deployed infrastructure today, one of the questions we ask in the decentralized identity space and emerging technologies around SSI is how we can leverage this existing technology on the web today and extend it towards a more self-sovereign or decentralized identity approach. And OpenID Connect Credential Provider is another one of those technologies that is aimed at bridging these two worlds and providing a solution that marries the new world with the old. In essence, OpenID Credential Provider is about providing a way for an OpenID Connect provider, which is the component that is responsible for doing end-user authentication and issuing out an end-user identity back to the relying party today, can be extended to become what we call a credential provider. And the basics of the flow essentially entail a mobile wallet or a user-selected application that a user would like to store a credential in, which we tend to call the wallet, making a request to their OpenID Connect provider, acting as a credential provider, requesting a credential and receiving it back into their wallet so that it is there for them to use later with relying parties. The way we intended to design this approach was in order to maximize the reuse of infrastructure that's deployed today, we wanted it to extend off the core of the protocol. That meant it couldn't break any of the existing protocol and it had to be in keeping with the original design intent that the OpenID Connect protocol was built with. It's also extendable, so it's designed to allow for multiple credential formats and different binding mechanisms, such as using the emerging technologies known as decentralized identifiers. So, the basics of the flow, for those familiar with OpenID, will see this flow as quite familiar. And the only change we have made in the core tenet of this flow is changing the intent of the request to become what we call a credential request. Instead of it being an ordinary OpenID Connect request, it's an OpenID Connect request, but requesting something beyond the normal artifacts of an OpenID Connect flow. Instead, our request is a credential request. You'll note that after launching the request, the client, that is typically the user's mobile wallet or application where they are collecting their credentials for later use, you will make that request to the OpenID provider, which is acting as a credential provider in this instance. That provider is then likely to challenge the user to authenticate. Many will be familiar with a username and password flow, but that authentication can be anything set out by the provider. And following successful authentication and consent, a credential would be issued and sent back to the client. For those familiar with the details of how OpenID Connect looks at a payload and protocol level, what we have done is defined a new scope. The reason we've defined this new scope is because fundamentally we believe a credential is a different type of resource that the client wallet in this instance is requesting beyond the normal resources or the normal identity assertion known as the ID token that is requested within the OpenID Connect flow. And so this scope is what we use to indicate the intent of the request and indicate that the request is in fact a credential request. The other things we have changed or added into in order to create this credential request is fundamentally a credential has to feature some form of binding to the client requesting it to the wallet, some cryptographic material so that the credential itself is reprovable with an authenticated mechanism using cryptography. In order to do that, the client on making the request needs to prove possession of the cryptographic material that the credential is going to be bound to so that the credential provider can authenticate this up front before they issue the credential. And the way we do this is by using the signed request object, which is defined in the OpenID Connect core protocol. And we also define inline where the key material to use in order to sign this request. sub JWK. Notation was taken from Chapter 7 in SIOP, and it essentially just inlines a public key required so that the OpenID provider can authenticate the request by using this public key to authenticate the signed request object, and therefore be sure that this key material it's going to bind the credential to the party that launched the request is in possession of the associated private key. We've also added the option, in the pursuit of continuing modes of extensibility, the ability for the client to request the format they would like the credential to be in. So this enumeration will be made available by the provider at the OpenID metadata endpoint, advertising which formats they support, and then the requesting party or the client can then select within that, making their selection explicit in the request. They also have the notion, based on the claims request syntax that is defined within the OpenID protocol today, to explicitly selectively request which claims they would like present on the resulting credential they were issued. Note that this request syntax is optional, and it is only for those who want to have a credential issued that does not contain the default set of claims and instead a subset. The response is essentially a new top-level element. This snippet here is taken from the token endpoint response that you will get through a backchannel based flow, and you'll note here, for those familiar with OAuth and OpenID Connect, that there is a new top-level element present here that is called credential, that contains the issued credential and the format information, so what format that credential is in. So those who are acutely aware in using decentralized identifiers technology will note that the first example did not include a DID. The reason we have done this is to make the usage of DIDs optional and extensible. So an OpenID Connect request example that uses DIDs adds one extra member to the OpenID Connect request, as you can see here, which is the DID. And instead, when a DID is present, the credential is in fact bound to the DID rather than to the key material directly. In doing that, the response may look a little bit more familiar to those who are familiar with verifiable credentials, that the ID property is instead populated with the DID that was present in the request and is used to create the verifiable credential that is received from the token response endpoint at the end of the flow. Now, with this protocol, as many will be aware, with OpenID Connect, it defines a way in order for a provider to advertise the capabilities it supports within the OpenID Connect ecosystem. We have defined several new metadata elements in order for the providers to express the different options and different elements that they support that go into supporting OpenID Connect Credential Provider. These include whether or not the provider supports decentralized identifiers, beyond that, which methods they support, the way that they indicate support for OpenID Credential Provider in the first instance is expressing through the credential supported attribute, and furthermore, which formats they support, and finally, which claims they support for the credential. Because the provider is the provider of a credential, it pays the last section of information, provides use for a wallet or a client application that is launching the request to be able to render to the user prior to making the request what they are likely to see in the form of a credential at the product of the flow. Now, it's often useful in order to be able to create a URL that is invocable by the client or the wallet application that is used to render the offer. We have elected to use the OpenID scheme that is used in Chapter 7 in SIOP, and the intent with this URL is that the URL itself, when clicked on a registered client such as a wallet, will render and have that wallet discover the OpenID provider, going to the OpenID well-known metadata endpoint and discovering metadata such as the following elements, and using that to render a UI prior to the user then clicking on and proceeding with the credential issuance flow and receiving the credential into the wallet. So this URL is just a convenient way in order to create a construct that is invocable by a supporting wallet application that elects to support this URL scheme.